Hi students, let's look at this question which was taken from the year 2022 paper 2 question 5 of the A-level paper. This question is on application of integration. Let's see how we can do this proficiently. So the diagram shows a path of circle x squared plus y squared equals to r squared. What this signifies is, it just implies that the center is 0, 0. Okay, center is 0, 0. And the radius is actually just r, right? Okay, so we label on the diagram, what you'll see is actually this height here is our radius r. This is as well our radius r over here. Right, these are all r. Great. Then after which we are told that the horizontal line here, r minus h. R minus h, take note, r and h are constant, so this is a horizontal line r minus h. So if this is r minus h, it will just imply that this height here, because this is r, right? This is 0. This is this point here is 0 r. So this is actually r minus h. So it just implies that this height here is actually our h. Alright? So r minus h will give us this entire r here minus h will give us, obviously this is r minus h over here. Okay, that's the idea. Now if you look at the question, the shaded region between the circle and the lines rotated about the y-axis forms a solid, and this solid is called a spherical cap. Alright, so the height of the spherical cap is h, so this is what we labeled just now, which is, it confirms what we analyzed just now. So show that by integration, the volume of the spherical cap is given by this. Okay, so this case here, you know that this is revolving about y-axis, so it has to be pi x squared dy. Okay, then you need to put the boundary there. So in this case here, it looks like that. So this is a spherical cap here. So essentially, we just need one shaded area here, then we rotate it about the y-axis. All right, then as you rotate, it looks something like that. Okay, the volume, it looks something like that. Okay, I hope you can visualize this. So this is just a simple rotation here. So essentially what we need is the required volume. We do from the lower bound, which is r minus h, to r, right? Then it should be pi x squared dy. So x squared is actually just make x squared the subject. So x squared, so r squared minus y squared. So this case here, just replace the x squared in. What we'll get here is pi r squared minus y squared dy. So treat the r squared as a constant. What we'll get is pi r squared y minus y cubed over cube. The r squared is a constant, okay? So this is r cubed over 3. They're going to replace the value in. I think we need to probably expand later. So this is a definite integral. We're just going to replace, substitute the value in. There you go. Then what we're going to do is just simplify this. So I just binomially expand this person here. Okay. So then after which we just, so remember we just replace this boundary condition to the y and the y. Okay, not the r. Don't get confused there. So a lot of things we cancel out, and we are able to show that the volume is this expression here. So let's look at the second part. An ornament is made from the solid sphere, and you remove a radius 15, and by removing two spherical caps, so one from top and one from below, like what we did just now. So in other words, this is a height, the first height, the height h1, this is h2. Okay, so one of the height is p, and from the top sphere another p3. The plane faces are parallel, so meaning to say these two are parallel, the plane face. Okay, what does it mean to be the plane faces? Because this ornament will look something like that, right? So if I were to revolve around the center, it looks here something like that. Then what it means is this face and this face, they are parallel to each other. These are the two plane faces of the ornament, right? Okay, so this and this over here, they are parallel to each other. So if these two are parallel to each other, okay, the volume of the ornament is shown in shaded is actually this guy here. So find the cubic expression satisfied, equation satisfied by p, and hence find the value. Okay, so we are given, so we're going to use this ornament volume here. One on top will be this guy when height is p. Then one for the below one, this is the same thing, right? The height is 3p. So take the total sphere minus the spherical cap on top and spherical cap below, and they will give us this total volume here, right? So that's what we're gonna do. So this is what's going on. This volume of the ornament was given to us, which was 3402 pi. It will be basically the radius now is 15, you take the the volume of the sphere minus off the top cap and the bottom cap. So remember to use the volume for the cap from the first part. So this is 1/3 pi p h square, right? So p square 3 times 15 minus p. Okay, then for this guy here, same thing. We just use 1/3 pi 3p square 3r, which is 15, minus h, which is actually 3p. So we can solve this. I think the good thing about this solving this is essentially we just divide everything by pi, right? Cancel the pi for each term here. Okay, this, and this. Okay, divide by pi. Then we just try and simplify everything. So we can GC and solve. P will be minus 2.5157. Then we have got p equals to 3. Then obviously we need to reject some of them, right? I think 2 of them. So reject as p obviously is less than half a r. It cannot be more than 15, right? Because 3p, actually 3p is less than r. 3p is less than r. Okay, which is less than 3. So similarly with this one, reject as p has to be positive. Okay, so this case here, what I get is actually p is just equals to 3. There you go. So that's the second part, B. So let's look at the last part. A different ornament is made by making 2 parallel cuts to another sphere of radius 15. So this is the same cut here. So you say that the top face of the second ornament has the same radius as the top face of the ornament in part B, assuming this is the top, okay? The top here. Did they say this is the top? Yeah, it's the top. Okay? And the bottom is... So then the bottom face of this ornament has the same radius as bottom face here. But the volume has to be smaller. Okay? So in other words, when you cut this 2, it has to be... This is P. So you cut the other cut of this length here, right? So if you cut this length, you have a similar length bottom. Don't forget that you can also go to the top here. So the cut that you want is actually this cut here. Okay. So you just copy the what you want is copy this length here over to the other side. So this ornament will have the same radius as the previous one. The top face and the bottom face, they will have the same radius. So but the volume will be smaller. So this is it, right? So we're told to find the volume of this this new ornament. So the new volume, when we revolve this area here about the y-axis, it will look like that, right? This is a new ornament. So the required volume is actually taking the top cap of 9, the height of 9 cm, then minus up the volume of another top cap, which is a height of 3. Okay. So using the result from the previous one, which is part A, your 3p square here, 3r minus 3p, minus of 1/3 pi p square 3r minus p. Then you just replace p as 3 into your answer. Okay. And r is 15. There you go. So what I'll get is actually 846 pi. Okay, cubic centimeters. So that's how I do this question proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.